Hey guys, my name is Tensor. Welcome to another Flutter tutorial video. Today we're going to be taking a project that we built in the Golang protobuf Docker tutorial, and we're going to be using the server that we built to interface with a gRPC Flutter application. I will be going over some general information about gRPC and protocol buffers, but if you want to get the more technical explanation, then I highly recommend you go and you take a look at the beginning of my Golang protobuffer tutorial, and I'll link that specific video in the description of this video so that you can just quickly go and look at it. At their core, protocol buffers are a language-neutral, platform-neutral, extensible mechanism for serializing and deserializing data structures. You can kind of think of it like XML, except much smaller, lighter, and faster. And the main use case for this binary serialization format is to allow different services to communicate with one another over RPCs, or remote procedure calls. The basic idea behind RPCs is just to allow one service to call to another service over some kind of connection as though the former service was a local service. So it's almost as though I'm able to define functions and then execute those functions between the two services as though they were one monolithic service. In this case, the application that we're working with is essentially just a simple client-server chat application. So here we've got the Go server, which we're going to be using even with the Flutter application. And then in this command line, we have the actual client. And as you can see here, I've specified that I wanted to name the client Tensor, and then I can go ahead and start typing in messages. So for instance, I can type in hi, and you can see here we have the ID of the user, which is just a SHA-256 hash of the name plus the timestamp, and then that is followed by the actual message that is being passed to the server and then back to the clients that are connected to the server. If we go to the actual server command line, you can see here it says sending message to, and then it gives us the pointer to the client that it's sending this message back to. If I was to open up other clients, then we could send all of these messages between all of the clients simply by doing what we're doing here. For example, I've spun up yet another client here, and I can go ahead and start sending messages. So I'll say hi, and then on our other client, you'll see here it'll actually give us the ID from the client that just sent hi, and it'll also give us that message. And then over on the server, you can see here that it sent the message to our original client and it sent it to our new client. And so if we were going to have like 3 or 4 clients, then if one client sends a message to the server, then it gets spread out to the other 4 clients, and so on and so forth. Now all of the data structures and the actual RPCs was defined inside of this little data structure here, which is our protobuffer file. To define the protobuffer, first we need to define the syntax that we're going to use. In this case, we're using proto3. Then we want to define the package for the protobuffer. And then we start to define data structures after we define the package. So here we first have a user data structure, which has 2 strings inside of it. One is an ID, and then the other is a name. Now, if you're wondering about these numbers here, these are just numbers that indicate how we look up these data structures when they get serialized. So if you think of the user like a hash map of sorts, it gets sent through as bytes, and we need some way of identifying which part of the user is the ID and which part of the user is the name. So we have this 1 and this 2, and they're sort of like keys which correspond with these values here. Along with the user data structure, we have this message data structure. This one has 3 strings instead of just 2. We have an ID for each message. Then we have a string with the content, which is the actual message piece itself. And then we have the timestamp, which is the timestamp that gets generated when the message was sent. The ID here is the ID of the user, And if you wanted to make this application display the usernames, you could just change this ID into the username. Now down here we have a connect structure, and this structure is used to define what happens when we connect to our server. So we connect to the server and we need to send in the user that's connecting and a boolean to tell the server whether or not this connection is active. Then when we disconnect from the server is going to send back a close structure, and as you can see here, it has no data inside of it. So it's essentially just a flag to tell the client that it's alright for it to disconnect from the server. To make the RPC actually work, we need to actually define a service so that the client knows about the different functions that it can call on the server, and the server knows about the different functions that it needs to implement. Our first function is this function called CreateStream, which takes in the connection structure and then streams out a bunch of messages. So the client can call CreateStream, pass in the connect with the user inside of it, and then it will start to get all of the messages back. Broadcast message function, where it passes in a message and then it returns a close. Then the second function here, called broadcast message, is what we use to describe how we get the messages from the client to the server. So we send in a message and then it will return a close, and the close is not really important unless we want to detach from the server itself. Alright, so now that we've gone over the protobuffer file, I've went ahead and generated a Flutter application inside of this folder here called gRPC client example. Before we get into the Flutter code though, we need to grab an actual binary for Dart, and we can do that by calling pub global activate prodoc_c plugin, and this is the Dart based proto_c plugin, which will help us generate the files that we need from our protocol buffer file. Once we've installed that, we can go ahead and actually generate the files, and we'll use this big old command to do so. So first we call to the prodoc_c compiler, and again, if you don't know what this is, I do recommend you go take a look at that Go video that I mentioned before. Then we're going to point it towards the include files, which are all inside of a little folder called third party. Then we need to point it towards the actual protocol file, so just the folder with our protocol file inside of it. Then we're going to say, all right, well, we want this plugin to use the protocol gen Dart plugin, which we just brought in, and we need to pass in the path where this bat file exists. And as you can see here, it exists on the user profile, app data, roaming, pub, cache, bin, and then the actual file is called prodoc_c-gen-dart.bat. Then because we're generating Dart files, we pass in --Dart_out, and we want to define where we want these files to be generated. So I'm passing in gRPC chat example /lib/protos, which is a folder that I created in our Flutter application. And then I need to pass in the main file that we're going to be generating all of this from, which is inside of our proto folder, and it's called service.proto. Now if we open up our Flutter application inside of Visual Studio Code, you'll see here that 4 different files were generated inside of our protos folder. We've got this service.pb.dart file. We've got a service.pb_enum.dart file. We've got a service.pb_grpc.dart file. And we've got a service.pb_json.dart file. The 2 files that we want to worry about in this case are the service.pb.dart file and the service.pb_grpc.dart file. The main pb.dart file is just used as the generic file, and then the pb_grpc file is used specifically for gRPC, which is what we're going to be using for this particular client. If you wanted to use JSON RPC, then you would use this pb_json file, and then if you had enums inside of your protobuffer file, you would have some information inside of this enumeration file. Now for our application, we're going to need a few different dependencies. We're going to need gRPC, which currently is at version 1.0.1. We're going to need protobuf, which is at version 0.13.4. And then we're going to need crypto, which is at version 2.0.6. Now the reason we need crypto is so that we can actually take the username and hash it as a SHA-256. If we weren't going to do that, then we wouldn't have to bring in the crypto library. Now that we have these dependencies, we can start to create a ChatService class, which will allow us to define the various pieces of logic that we want to use to interface with our server. In here, I'm importing the gRPC service.pb.dart file and then the service.pbgrpc.dart file. And I'm also importing the gRPC library, I'm importing the crypto library, and I'm importing Dart convert. We'll start by defining two properties for this class. We're going to need the user, which is being logged in. And so we'll just say user equals user. And this will just give us an empty user data structure. And then along with the user, we're going to need what's called a broadcast client, which is the actual client that we're going to use to communicate with the server. We'll make the broadcast client static so that no matter where we are inside of our application, we're always calling to the same instance of this broadcast client. Now let's create a constructor for this class. To create a new chat service object, we want to pass in a single string, and this will be the username. We can use this string to set up our user structure. And first what we'll do is we'll call clear name on the user structure that we generated up here, just in case, and then we'll take the name that's coming in through the constructor and put it onto this user object. Then we'll clear the ID, and then we'll generate the ID using the SHA-256 convert method along with the UTF-8 encode method on the user name. So UTF-8 encode converts our string into a list of integers, and then we can use that list of integers to convert it into a SHA-256 digest, and then we want to convert this hash into a string, so we use the toString method. Now notice that we're using the Cascade Operator to do all this stuff. If you look at the actual user object, there are no items that are passed into the user object constructor. And if you want to add to the fields of the user object, then you just use Cascade operators, or you just use the dot operators. The same is true for all of our gRPC objects that we generated with our protocol buffer. And you'll see more of that as we walk down through this service. Now let's go ahead and set up the client. And remember, our client is static, so if we set it up once, then it will be exactly the same every single time we call to one of these chat service objects. So first we want to open up the broadcast client constructor, and inside of it we need to pass in what's called a client channel, and this contains all of the information that we need to connect to the other service, which is our server. So first we need to pass in the address. Now, because my server is running on the local host, and because the Dart application is running on an Android emulator, we need to use this special IP address to access the local host from the emulator. So we pass in 10.0.2.2 rather than localhost or 127.0.0.1. After we pass in the address, we can pass in the port. Remember, our server is running on port 8080, so we just pass in port 8080 for this. We then want to add some options to our client channel, and we can do this through a channel options object. Specifically, we want to just tell the application that we don't need any kind of special credentials to gain access to the RPC because we're not running it over HTTPS, for instance. So we just say credentials equals channel credentials.insecure. If you follow it along with the Go tutorial, you'll notice that some of the code actually is very much the same as what we're writing in here, and that's not by accident. Alright, so now that we have the constructor, we can go ahead and define the methods that we'll use to essentially call to the RPC methods. So first we'll define a method called sendMessage, which will take in a string, which will be the actual message's body. And then this will return a future of close type, with the close type being our RPC close type. All we really want to do is wrap this around a call to client.broadcastMessage, which is the name of the RPC function. And in here we just need to pass in a message object type, which is the message that we're passing to and from the server and the client. Like with our user, our message doesn't have the fields inside of the constructor, so we need to define the message and then use the Cascade Operator to set up the actual fields. The setup of the message is actually pretty simple. We'll pass in the user ID for the ID of the message. Then we'll take the string that's being passed in here and we'll pass it into the content field, and then we'll generate the timestamp field by calling dateTimeNow to ISO 8601 string, which will generate a specific type of timestamp. Now let's go ahead and create a method called receiveMessage, and this will be a method that will emit a stream of message type inside of it. And because we're emitting a stream like this, and because it's going to actually generate this stream, we need to pass in that this is a sync star. First, we'll define the connect object, and as you can see here, it's like our message and our user, where we're just using the cascade operators to define the fields. So connect has a user inside of it, so we'll pass in our user, and then it has this active boolean, and by default we'll pass in true. Then we can use an await for loop to get all of the various messages from calling client CreateStream, and in CreateStream we're going to pass in the connect. Remember, in our protocol buffers file, we defined that RPC function called CreateStream, which takes in a connect and then streams back a bunch of messages. And we can of course use this to our advantage by essentially just taking all of the messages, awaiting for them, and then passing back the messages as a stream of messages here. And that's all the logic that we're going to need for this particular class. Let's now go ahead and build out our user interface. So inside of our main.dart file, I've just got the basic app structure. So we've just got a stateless widget here, which builds out our material app widget. And then this points to a login page, which is a stateful widget. And then this just builds out nothing. Ideally, the way that we want this to work is to have the login page just be a text box where the user enters in the name that they want to use for the chat, and then we'll go to another page where the user will be able to enter in chat messages and see messages that are coming back from the server. Inside of the login page's login state, we need to set up a text editing controller because we're going to have a text field. Then we'll set up the scaffold, and we'll just have the AppBar display a title which will say choose a username on it. The body of the scaffold will just be a center for now, and then we'll go ahead and actually create the user interface inside of this center. So inside of center, we have some padding, and we'll make it so that our actual text field is more towards the center, so we'll make the padding horizontal. And then we'll have a column where we'll have a text field with our controller inside of it, and then below it we'll have a button which will allow us to submit the text inside of the text field as the username. Now is a good time for us to go ahead and import our chat service and then the protos service.pb.dart file so that we can actually reference the different types and also access the chat service. Now down here inside of our material buttons on pressed function, we'll call navigator of, pass in the build context, and then we'll push in a material page route which will go to our next page, which we'll call MessagePage. And we need to pass in a builder which takes in the context and then passes back the next page that we want to move to. The MessagePage will take in our chat service and will pass in the controller's text as the chat service's name string. So this will go into the user field, and then it will become the user that's inside of this object. Now for the message page, again, we're going to need a stateful widget. And because we're passing in the chat service, let's make sure to actually pass it into the constructor here. So we'll define a chat service and we'll make it final, and then we'll pass it into the constructor like this. Now down inside of the message page's state object, we want to set up a text editing controller, and then we'll set up a set of messages, and this will be our internal state of all of the messages that we've received back from the server. Now the reason why we're using a set rather than a list is so that we can deal with duplicates, and the set will automatically just remove them. We of course want to set up these two items with our initState function. So we'll just say messages equals a set object, and then our controller equals a text editing controller. Now let's build out the UI. Again, we need to create a scaffold, and for the AppBar we'll just say that this is the chat page, and the body again will be inside of a center widget. In our center widget we'll have a column, and the children of the column will start with a padding with the same edge insets that we had from before, so it's just a horizontal padding item which will push our text field towards the center, and then inside of the padding we'll have our text field which will be attached to the controller. Now we can go ahead and add a material button, and this will just have a submit piece of text on it, and the idea is that we'll be able to submit the messages in the text field to the server, and then they'll be passed back to our ListView. So to submit the messages, we can call widget service send message, and then we can pass in controller.text, and then we want to clear our controller or our text field, so we can call controller.clear. Then after the material button, we want to set up our list. So we'll first start with a flexible because we're going to be putting another vertical list inside of a column. Then we'll set up the stream builder because we're going to use the receive message stream to build out this stream. So we'll use the snapshots that we're getting back from this receive message call to essentially build out the list that we're going to have. If we do not have any data in the snapshot, then we want to display a center with a circular progress indicator inside of it so that it looks like it's loading. Otherwise, we want to take the data from our snapshot and directly pass it into our messages set. Finally, we can use the messages set to build out a list view. So we return this list view, and then we can say that the children of this list view will be our messages set. We'll map over the messages set, and for each message we'll create a list tile where the leading tile is the message.id, and we take the first 4 letters of the ID, because if you remember, the hashes that we were creating were rather large, so we just want them to be fairly small in this case. Then we'll have the title, which will be the actual message content, so this is the content of the actual message itself. And then we'll have the timestamp be below it in the subtitle field. And of course, because we're mapping over our messages set, we need to convert all of these widgets into a list of widgets. So we can just use the toList method to do that. And that's actually all we need to do for our application. So we can go ahead and run this application, and if we go ahead and run our server in our command line, we should be able to actually connect to the server using this Flutter application. So first I'll start the server, and then I'll go ahead and start one of the clients so that we have at least one client running while we also have our Flutter client running. If we take a look at our emulator, you can see here's our application. So I can go ahead and type in a name for this user. Let's just call him test. And then I'll hit the submit button. Once I do that, we go over to the chat page. Let's type in hi and click submit. And you can see here that the hi message now appears on our list view. Also, you can see in our RPC, we have the various different messages being sent out to the clients. And we can see that hi has appeared inside of our command line client as well. Of course, I can go ahead and respond to the Flutter application from the client. And as you can see here, it now shows up in our list view. And it also has a different ID next to it because this hash is, of course, different than the hash that was generated by our application. We can keep sending in messages, and of course, this will just work like a chat application. Alright guys, well I hope you enjoyed this tutorial. If you did, feel free to like and subscribe. If you have any questions or comments, feel free to leave them in the box below. And if you disliked this video, then by all means downvote it as much as you like. Have a good night.